Dear viewers, after 2 decades of groundbreaking scientific research in human habitation in low Earth orbit, the International Space Station is reaching its life. As the ISS nears the end of its lifespan, NASA is planning its controlled demise, a complex and costly operation that will symbolically mark the end of an era of international cooperation in space exploration. Its aging structure and the accumulation of wear and tear have raised concerns about its sustainability and safety for further missions. In light of these concerns, NASA, the lead agency responsible for the ISS, has embarked on a plan to decommission the station in a controlled and responsible manner. The target date for deorbiting the ISS is set for 2031, marking the culmination of an extraordinary era of human presence in space. The decision to decommission the ISS was not taken lightly. Extensive studies and evaluations were conducted to assess the station's current condition and its future viability. The results indicated that maintaining the ISS beyond 2031 would require significant investments in repairs and upgrades, which would divert resources away from other space exploration initiatives. As the ISS approaches its retirement, NASA is shifting its focus toward the next chapter of space exploration. The agency is investing in the development of commercial space stations, which will provide a more sustainable and adaptable platform for future scientific research and technological development. As the ISS reaches the end of its operational life, the question arises of how to safely and responsibly dispose of this massive structure. 3 primary options have been considered for deorbiting the ISS: controlled re-entry, uncontrolled re-entry, and pushing the station into a higher orbit. Each option carries its own set of advantages, disadvantages, and potential consequences. Firstly, controlled re-entry is considered the safest and most environmentally responsible option for deorbiting the ISS. This method involves utilizing specialized spacecraft or propulsion systems to precisely guide the station's descent into Earth's atmosphere. During re-entry, the station's components would gradually disintegrate due to the intense heat and friction, with most of the debris burning up in the atmosphere. The remaining intact pieces would be targeted to fall into a remote, unpopulated area of the Pacific Ocean, minimizing the risk of harm to people or property. An uncontrolled re-entry, also known as passive re-entry, involves allowing the ISS to gradually lose altitude due to atmospheric drag. This method is simpler and less expensive than controlled re-entry, as it does not require active propulsion or complex maneuvers. However, it also carries greater risk, as the precise location of the station's re-entry cannot be fully controlled. Some fragments might survive re-entry and potentially impact populated areas, posing a safety hazard. Finally, pushing the ISS into a higher, non-Earth synchronous orbit is another potential option. This method would involve using propulsion systems to boost the station's altitude to a point where it would naturally decay over a much longer period. The decision of which deorbiting method to employ will depend on a careful assessment of risks, costs, and environmental considerations. Controlled re-entry is considered the safest and most responsible option, but it also comes with the highest cost. As the ISS nears its retirement date, NASA is actively seeking proposals for a spacecraft capable of safely deorbiting the station. The agency has estimated that the cost of this endeavor could reach up to $1 billion, reflecting the complexity and precision required for such a delicate operation. In September 2023, NASA released a solicitation for proposals seeking industry partners to develop a deorbit vehicle, also known as the U.S. Deorbit Vehicle. The USDV will be tasked with the critical mission of maneuvering the ISS from its current altitude of approximately 250 miles to a lower altitude where it will naturally re-enter Earth's atmosphere. The USDV will provide NASA with an independent capability to deorbit the ISS, ensuring that the station's retirement can proceed as planned, regardless of external factors. The deorbiting of the ISS is a complex and challenging operation that requires meticulous planning and execution. The USDV must be capable of precisely controlling the station's descent through Earth's atmosphere, ensuring that most of its components disintegrate safely and that the remaining debris falls into an unpopulated area of the Pacific Ocean. To achieve this level of precision, the spacecraft will rely on sophisticated navigation systems, powerful propulsion capabilities, and a deep understanding of atmospheric dynamics. Any errors in calculations or execution could lead to catastrophic consequences, making the deorbiting operation one of the most challenging undertakings in space history. The deorbiting of the ISS is not solely a NASA endeavor. It requires close coordination and collaboration among the international partners involved in the ISS program. These partners include the United States, Russia, Japan, Canada, and the European Space Agency (ESA). This is today's video. Hopefully NASA and their partner space agencies will be successful in their mission to deorbit the ISS. Thanks for watching. Also subscribe to the channel.